All right, good morning, folks. Today we're going to look at testing and debugging. Our programs are going to get more complicated as we go throughout the semester. So being able to have some tools for sort of figuring out what happens if you're getting the wrong result. So various sort of testing techniques or debugging techniques are going to be important. So we're going to look at a few different ways today. One of them will be using the Eclipse debugger. So hopefully this will be useful. The debugger is a very important tool, especially once you start getting much more complicated codes. It lets you sort of see your code from a different perspective. You can sort of execute your code line by line and see exactly what the computer's doing, which can be quite useful for figuring out if there's an issue or where the issue might be in a more complex program, which is certainly what we're going to be encountering in the near future. So the sort of key things here when it comes to testing your programs is to always try a variety of input. Even values that maybe you wouldn't think to try. If you're writing a program that's doing a quick calculation, maybe you don't expect some user to enter a negative value, for instance. Maybe that doesn't sort of mean anything useful to your code, putting in a negative number. But users do all sorts of weird things. This is why in a lot of video games there are bugs that just don't get caught because users do very strange things when they play video games. So this happens in all sorts of codes where just a user might enter something you don't expect and maybe you didn't account for, which could cause some sort of error. So you definitely want to test a variety of different types of values, and don't just test a few. Pick more values to test. At one point when I was a postdoc, I had done a bunch of testing on a sort of certain part of my application, and I'd only tested very sort of simple cases. So it's sort of the equivalent here of testing maybe one or two values that didn't have a very big variety. And so I thought, all right, everything's working great, awesome, let's do some production runs. Turns out that what I was using to test was just too simple to show errors in the more complicated parts of my code. So don't just try one or two values with sort of all sort of almost the same. Pick a variety of inputs and then test a bunch of them. In particular, you want to test interesting values. So these are those sort of edge cases that I talked about on Tuesday. Something that would potentially send you into a different part of an if-else block, for instance. Something that would either sort of be right on the edge of sending you into the if part or into the else part of an if-else statement. So these will sort of show you, did you program those conditionals correctly? Did you program this if-else correct? So these are sorts of the sort of general sort of ideas of what you should be testing and potentially give you an indication of the values that it would be useful to test. So I have a few cartoons here that are sort of related to this. The author of these, this is from XKCD. So if you haven't checked out that comic, it's quite good. It's sort of a sciencey computer science style comic. So there's a lot of good ones in there. So things like this, my code's crashing given pre-1970 dates, and of course that is an epoch fail. So stuff like that, stuff like finding errors and in this case pre-1970 dates. You definitely want to be nice to your computer. This is a pointer joke, so if you haven't used a language where you've explicitly messed with pointers, this may not make a ton of sense, but in the future you definitely will. So something like the computer talking to the guy, hello human, before you compile, listen up. And then sort of gives a scenario here, when you're falling asleep and you're walking and then maybe you stumble or something and you jolt awake. That's what a seg fault feels like. If you haven't experienced a seg fault or have had a segmentation fault happen when you've run codes, it's essentially a crash. That usually deals with memory. And so the computer says, double check your damn pointers, which deals with memory. So Java, we don't have to deal with memory as much, but other languages you definitely do. Oftentimes, this is what debugging feels like. So you run your program, you pull the lever, and something bad happens. So you get zapped by lightning here. And then you're like, all right, what's going on? A normal person probably is going to be like, all right, maybe I shouldn't do that again. Us, on the other hand, we're going to run our program again. We're going to say, I wonder I wonder if I get this error every time I run it. So that's the idea here. When you're doing debugging stuff, you're going to keep running your program over and over again and seeing what happens, wondering, does it do that every time? Does it crash like that every time I run the program? So we're sort of on this sort of scientist end of getting zapped by lightning. And sort of lastly here, this one here is it's a sort of a programming thing. I could restructure the program's flow, so in other words, do a whole bunch of work, or use a little goto instead. Now, Java doesn't have goto statements. Languages like BASIC and Fortran and stuff like that do. They're very bad. You should never use a goto. If you're working with a language that has a goto and you're in one of my classes, then and you use a goto, then that would be very bad. That would be very detrimental to your grade. So this guy says, all right, screw that, screw good practice. How bad could it be? Puts a little goto in, compiles it, and then gets attacked by a raptor. So definitely don't screw good practice. Try to keep good practice at sort of the front of your mind. Otherwise, you might get attacked by a raptor. So there's a whole bunch of cool comics like this. So if you've never seen XKCD before, it is a very cool comic, and there's a lot of sort of computer sciencey related things that either you'll find funny now, or after programming for a while, you will most likely find quite funny. So I want to start by talking about a bug in the Microsoft Zune. Now, this is Microsoft doesn't make Zunes anymore. Think of sort of iPod style thing. This occurred in 2008 on December 31st. So, and I don't know exactly what sort of firmware it was, what sort of a specific version of the software it was, but their press release mentioned the 2006 model of the Zune, and they had a technical problem. So on that day, December 31st, 2008, there was a bug in their clock driver, and it was how it handled a leap year. So there hadn't been a leap year yet. This was a 2006 model. 2008 was the first leap year that this occurred on. They said it would basically be resolved over the next 24 hours. And I'm going to show you what this error is. I'm going to show you the actual code that caused this error. So they said, we expect the internal clock to automatically reset tomorrow. You let the battery run out, and then you charge it back up, and you restart it, and everything should work fine at that point. So basically, the Zune was basically dead for a day. It actually wouldn't respond to anything. You would sort of have it on or whatever, be trying to do something, and any sort of clicks or whatever, any sort of action you tried to do with it, it would not respond at all. So essentially, you had to let the battery run out. There was no way to turn it off. This was a coding problem. They say, okay, it's a bug in our internal clock driver. The bug was just this. This is the actual code that caused the problem. Now, we haven't talked about loops yet. That's actually coming up next Tuesday. But there's a couple of if statements here. And if you just sort of look over this and maybe sort of write out some examples of this, or just sort of give it a quick glance, it probably looks fine. It probably looks like there isn't sort of any sort of major issues here. But I'm going to point out a couple of things. And I'm going to use my little pencil here. We have an if-else, so this blue and the blue here. This is an if-else. And then we have just a single if right here. Now, there is an outer loop to all of this. And again, we'll talk about loops next Tuesday. But if you've done programming and stuff before, you will likely have encountered sort of loops before. The big thing that happened here was that they didn't check all the edge cases. They didn't completely check 365, which would be the last day of a regular year. 366, which actually has two interpretations. Day 366 is either the last day of a leap year or the first day of the next year. And then 367, which is the first day of the next year in a leap year. So those are our sort of edge cases, our sort of final day of the year / first day of the next year when this code is supposed to do its thing. So as an example, let's say we check if the year is a leap year. That's what this piece does. If this year is a leap year, that's essentially what the code is doing. If it's not a leap year, Then we skip all the stuff in this sort of first part of the blue if, and we go down to the else. We're subtracting 365 because right now we're sort of assuming that this is the first day of the next year. So it's day 366. Was it a leap year? No. Subtract 365, so we get to a day of 1, which is the first day of the next year. So we go back to days equals 1, and year is incremented by 1, so it would be the next year. So this will work properly for a regular year. But what if it's 366 and it is a leap year? Then we say, okay, it is a leap year. If day is greater than 366, well, it's not. Day equals 366. So we skip this red if, and then we're done because we've gone into the blue if. We skip the red if, and then that's it. We sort of go out to the end bracket here, which brings us back to the loop. This is what causes the problem. On day 366, this red if, skipping it actually causes a major issue. And it causes essentially what's known as an infinite loop. So if you've done sort of loop stuff before in programming, you'll know what that means. Otherwise, you will see it on Tuesday. When you're stuck in an infinite loop in a program, you can't do anything. This is what happened to the Zune. So we'll probably come back and look at this error a little bit later on, especially if you can't really decipher it right now. It can be a little bit tough to sort of decipher exactly what's going on with these different values. But if you sort of sit down and think, all right, what is the value for days? 365, 366, 367, and sort of test each one of those days, then you can sort of see where this is actually going to cause a problem. And that's it. This was the literal code in their clock driver that caused a problem. So whoever did the original coding for this never thoroughly checked 365, 366, and 367 to make sure it worked. And because leap years don't come around very often, it was years before the bug was actually found. And the nice thing about it, it only lasted for a day, because as soon as you went from 366 to 367, by letting your battery drain and turning it on the next day, this will have resolved itself. So it's one of those little things where even big corporations with these sort of professional software engineers can still come up with an error that someone in a CS1 class could potentially be able to fix without a whole lot of trouble. So this stuff does happen quite often. So being able to debug stuff, doing the correct amount of testing on your different conditions, your different sort of variables around the sort of edges of these if statements, that is a very useful skill to have to be able to find errors like this. So some general advice in terms of checking for errors is always look for common stuff. If you are running your program and you get an incorrect result, something that you don't expect, always check for stuff like using a single equals instead of a double equals. I mentioned that 3 times last class, so we'll mention it again as well. Check to make sure that maybe you're using a greater than or less than when you should be using the equal to equivalent of that. So this will sort of give you like an off by 1 sort of thing, which can happen quite often in counting. Maybe you should start at 0, but instead you write some code where you start at a value of 1. That would give you sort of an off by 1 error in terms of sort of counting things. So stuff like that. Intentional or unintentional integer division. Maybe you mean to do an integer division, but you accidentally don't, or you don't want to do one and you accidentally do by what you've programmed. So these are sort of the common errors that you're going to encounter in a CS1 class. Always test your code. There are unit tests. We're going to talk about those here in just a second that you run, but you should test your code as you write it as well. Don't just try to write your code and then run the unit tests and hope that they work. Test little small increments. So use some values. Deal with that deal with sort of edge cases. Use some values that are those interesting values that I mentioned. Now, if you do have an error, you have a problem with a calculation or something, you want to localize the error. Try to figure out exactly where it's happening. If your program is crashing, Java typically tells you where the crash happened. That may not be exactly where the error is, but it'll give you an idea. The big thing not to do is don't just change code randomly. Don't just start making a bunch of changes. You want to try to be very systematic about it. make one change in a place where you think there might be a problem, and then run the code again and see if you still get that error, or see if potentially the result changes in some way that is either good, maybe closer to the correct result, or maybe worse. So essentially, you're going to narrow down where an error might be coming from by checking values throughout the code. So by checking values, I mean using a print statement. So if you're doing some complex calculation, you could check each individual step. And I've done this all the time. If I'm doing a calculation, I'll break the calculation into multiple parts, and I'll just print out each part. That way I can see, okay, which parts are correct, or at least which parts do I think are correct, and which parts might not be right. If you're doing some massive calculation and one of those parts ends up being, say, 0, and you're multiplying that part by other stuff, that could be a problem, because then you're probably just going to get 0 out of the whole calculation, for instance. So being able to narrow down where the problem is by checking values using print statements, that can give you a really good indication of what's going on. For things like our if-else statements that we talked about last time, you can always throw prints or output statements into each one of the if and the else, or the else-if parts of that, to see which branch it's going into, so that you know, all right, which is it going into the if part? Is it going into an else if part? Is it going into the else part? That way it tells you what the program is doing so that you can diagnose these sorts of problems. So big thing, try to localize the error by making systematic changes. We do have some exercises today, and particularly one at the end where I'll break you out into groups. Me and Dan will sort of jump around, and it'll deal with using the Eclipse debugger. So we will be messing around with some today. So here's the first little example. I'm going to code this one up. I don't have this one already written. I have some of the other ones written, but I don't have this one written. And right now, it looks like, if you just sort of look over the code, sort of scan over it, it looks like it's probably going to work. It just computes the volume of a cone. So you input a radius and a height, and it does a calculation, and it gives you the volume. Now, if you look closely, you can probably figure out what the problem is. But I'm going to show you how you might go about localizing the problem, how you might go about thinking about how to find out exactly which part of the code is causing the issue that we're going to have. Again, this is a very simple problem, so you might be able to figure it out just by looking at the code, but we are going to code this one up. So I have essentially an empty file with a scanner already included in. You could always create a new project or use one of the previous ones that we were doing examples with in the previous classes. So for our cone, I'm going to create a few doubles. So we need the height, we need the width, and we're going to compute, or we need the height and the radius, and we're going to compute the volume. So that is that's basically the only 3 variables we need. And then we're going to have a little bit of printing. So we'll say enter height. I think I had a little bit more text in the slide, but this will be fine. And so we'll say height, we'll input next double. So hopefully this is stuff, after the first homework, for example, hopefully this is stuff that you're relatively familiar with, doing a print and then using the scanner to read in one of the values. I'm using next double, of course, because I've created these as doubles. If I was using ints for the height and the width, I'd want to make sure that this was next int. And then essentially the same thing again. So a print for entering the radius. We don't need the %n. And I'll say radius is input.next double. So I get my 2 values. I'm not going to worry about if the user types in a negative value here. That's something we'll actually look at in one of the next examples that's coming up. I'll just sort of make the assumption that the user is going to type in something that makes sense. So the next piece is the math. So we need the volume. And if we go back to the slides, we'll see that it is 1/3 times math.pi. This is using the math library. And we've seen the math library before for things like POW and squirt and abs, stuff like that, the sort of quick calculations that like trig functions and stuff like that. Well, it also has a constant for pi. So rather than using 3.14 or something as my value, I can just use math.pi in my calculation. So it'd be 1/3 pi r squared times the height. So that's our calculation. So it's 1/3 math.pi, and it has to be both, it has to be caps, so capital P, capital I, times radius times height. And spell radius correct. And there's our volume calculation. And then, of course, we're going to print it out. Now, from a sort of math book perspective, if I just had a math textbook open or something and I typed in this equation, this is how I would see it. This is how I saw it in, for example, a math equation when I opened up my math book. So we're going to say volume, and we're going to print out %f for printing out a float. And I'll put a new line in as well, and then I'll print out volume. Now, if I run the code and I type in whatever, 2 and 5, I just get 0. That doesn't make sense for the volume of a cone. I've entered in non-zero values for the height and the radius. I should not get a 0 volume. So there's definitely something wrong. Now, the localization here is relatively easy because there shouldn't be anything wrong with reading in the values, and there shouldn't be anything wrong with printing out the values. So really, it's got to be in my calculation. So to figure out exactly where this problem is occurring, there's a couple things I can do. I mentioned breaking up my calculation into smaller parts. So let's say I want to completely take out the values that I entered. So here's radius, height. So I can do something like this. I can just either delete them, or I can just comment them out and put a semicolon here, 1/3 pi. Let's just check and see if that's correct. That should be correct. It's just 1/3 times pi. It doesn't matter what I enter for the height and the width, or the height and the radius, because I've taken those out of my equation. And yet I still get 0. So I can take it even further. Well, math.pi should be correct. Otherwise, sort of all of Java all of Java's sort of math stuff would be broken if math.pi isn't correct. So that should be fine. So rather than sort of try to test if that's right, let's see if my 1/3 is what I want. So if I do this, and hopefully you see what the problem is now, I get 0 for this. So this is an integer division. That was the problem with the equation. And it's easy to do something like this. I make mistakes like this all the time, where I'm looking at an equation from a website or from a book or something, and I start coding it up, and I accidentally leave an integer division in there when there shouldn't be one. This should be 0.3333 and so on, but it's not. It's 0.333, but because it's an integer division, it cuts off everything at past the decimal point. So it's just 0. So to fix this, I would either need to do a specific kind of thing called a cast, which we'll get to sort of later in the semester, or I need to make sure one of these values is a double so that the whole thing becomes a double. So if I put 1.0 and save it and run, now I get my correct 1/3. And then I can get rid of the comment here. So I have my full equation back, run it again, and there we go. So that's the idea of this sort of localization thing. Check, especially in things like your equations, check to make sure if you're getting a weird value, just start cutting the equation into pieces and checking each of those pieces, because that can really help find where some of these problems are coming from. If you notice that it was correct, say after doing something that for the first thing, if you did this and this worked properly, but adding in the height and the radius were not, then you need to look at those values. Is something going on, something happening with those values between when they're entered and when I'm using them in the equation, for example. So there's a lot of these little techniques that as you use them, as you do more programming, that'll become second nature, to throw in some extra print statements or take an equation and break it up into smaller pieces to try to figure out which piece is actually not working right. So on this particular sort of debugging, sort of simple debugging example, does anyone have any questions? Okay, so I'll head back to the slides. I have a couple extra sort of slides here that sort of show like, all right, let's just take a little piece of this, check and see, and then this one, happens to be an integer division. So I have some slides here that sort of show sort of what you can do to try to catch one of these issues. All right, I have another one. We're going to do this one in two different ways. We're going to sort of do it in the way that we just did, and then we're actually going to use a totally different method to do it. So I have this one coded up already. It's just a simple sort of guessing game. I've already put the answer in, so I know that the answer is going to be 3. If you were using like a random number generator, for instance, then you may not know what the answer is right away. So it's useful when you're doing testing or debugging to just fix the answer to something so you know, and then you can test all the values around it. So things like, all right, I got to enter a value between 1 and 10. Those are going to be critical values. I should check 1, I should check 0, I should check 10 and 9 and maybe 11. Stuff that's around where I'm putting a restriction on. Because notice what this does. So you enter a guess, you read it in from the user. If, and you can look and see what this does, it's looking for the guess, sort of checking it's the guess between, the idea here is checking if the guess is between 1 and 10. If it's not, then you want to print invalid guess, or I guess looking and see if it's outside of 1 and 10, then you would print invalid guess and you'd exit the program. Otherwise, so if the guess is valid, you would check, does the guess equal the answer? And you print something appropriate, otherwise you would print that it's not. So you might be able to pick out some of the issues here already, but there's actually quite a bit wrong with this particular code. So we're going to go through it and just look at each of these pieces. We're going to try, a value of 0, a value of 1, a value of 2 for the guess, and see what prints out. And then we'll try 8, 9, 10, or whatever, 9, 10, 11, and we'll try sort of a couple of things. We'll input the right answer, we'll input wrong answers, and we'll see what happens with this. And then try to diagnose what's wrong with the code. So back in Eclipse, I have this one already set up. So this is that exact code. And it's exactly the way that you see it on the slides. So if I run it, I know the correct answer is 3 because I've already put that in here. So if I type in 3, I should expect to see, you got it. But I don't. I see wrong, try again. So clearly there's an issue somewhere in the code because I input the correct answer or what I coded as the correct answer, and it told me that I was wrong. Let's run it again. Let's try a value of 2. So this one said, you got it. They should be flipped. It should have said, I got it when I put in 3, wrong, try again when I put in 2. And in fact, if I put in something like, maybe let's try 7, it said, you got it. So we can look down and say, all right, it's something to do with when we actually put in a value that works. So we're not interacting with this if really at all, other than to just skip it. So it's got to be something down here. So if the guess is exactly equal to the answer, it should print out, you got it. I have these two backwards. I print them out in sort of the wrong case. So I can just take one of these and copy it and move it up here. Same thing with this one. We will copy this and move it down here. So now if I enter 3, it'll say, you got it. If I enter a 2, it'll say wrong, try again, and basically the same for sort of any of the wrong values. Now you might think, all right, good to go, ship it, put it up on Steam, we can make a lot of money. There's still issues with the code, however. So let's try putting in a value of 0. Now I say between 1 and 10. So let's put in 0, okay, invalid guess. That makes sense. I said between 1 and 0. Let's put in 1. Still gives me invalid guess. Even though my instructions to the user say between 1 and 10, I put in a 1, it says it's invalid. Let's try, we did 9 before. Let's try 10. Invalid guess. So 1 and 10, they didn't work, but they should have just said wrong, try again. So there's something wrong here when I'm printing out invalid guess. So let's think about it sort of slowly. Let's think about if I enter 1. So if guess is 1, I have this a little bit more complicated statement inside my if. So this is saying if guess is less than or equal to 1, or guess is greater than or equal to 10. Less than or equal to 1, or greater than or equal to 10. So if you see one of these sort of complex Boolean expressions, the things that we talked about last time, it's worth just sort of saying them out loud, or read them out loud to yourself, so that it will hopefully make sense as to what it's trying to do. Guess less than or equal to 1, or greater than or equal to 10. The equal to here might cause a problem, because if guess is 1, then this is going to be true. Guess is less than or equal to 1. So let's remove the equal here. Let's run. Let me put in 1. There we go. Wrong. Try again. That's what I expect. If I put in 0, then it's invalid guess. That's what I'm expecting the behavior to be. For the one that's 10, if I put in 11, invalid guess, that makes sense. I put in 9, wrong, try again, that makes sense. Put in 10, I get that invalid guess for the same reason. That equals there is giving me a problem. Because if I put in a guess that is equal to 10, it will also say invalid guess. So I need to get rid of the equals here. Now, for undoing stuff, there we go. Now when I put in the 10, now it tells me wrong, try again. So it's these little things. Oftentimes an error that you might have could just literally be one character. If I had an equals here, that's just one character, and it would mess up the execution of my program in certain cases. So you will find these quite often in the code that you write. I find them all the time in the code that I write. I need an equals when I don't put one in, or I do sort of an off by 1 thing. If I accidentally put a 0 here, then potentially that's going to give me problems. So it's sort of an off by 1. So try to localize the problems by using things like print statements. Here, there were already print statements basically everywhere, so that really helped. But if you have situations where you don't have print statements, adding them in is one of the simplest things you can do to help you debug. And that's probably the first place that a lot of people go to figure out what might seem like a simple problem. So usually after these slides, so I usually have some pop-ups or some other description of stuff here. So the conditional, it's supposed to include a guess of 0 and 1. We have a swapped input messages or swapped output messages. So here is that actual solution to this, is sort of the fixed exercise. So we're actually going to do this one again, but in a different way in just a moment. In every single assignment that you have for the class, there will always be unit tests. GitHub Classroom will, I have it set up so GitHub Classroom will actually run them as well. So you may see an email about the tests running after you sort of push stuff up, after you create the assignment. You don't have to worry about that until you're completely done, in which case I don't think it emails you when the unit tests finish running. But these are the things that I've showed you before. You can run them manually right through Eclipse. So when you run these unit tests, they're a good way to check your code, to make sure things are outputting correctly, and they're what I go off of for the most part for the majority of the points on any given assignment. The idea here is to write additional code that tests individual pieces of your program. So that's actually what's happening in the unit tests that you run. There's some extra code that's written, and they're there, the unit tests are there to ensure that whatever your code is outputting is what it should be outputting in terms of whatever you expect. So in some of the bigger codes that I've worked with, things like National Labs and stuff, there were potentially hundreds of unit tests. And depending on sort of code that you were working with, the piece of the code you were working with, you probably would want to change up which unit tests actually ran. The code that you're working with for your assignments, typically there's on the order of maybe 3 to, or maybe as little as 2 to maybe 10 tests total. The unit tests have to be correct as well. So it's not something that is just made for you and just works. You would specifically have to write the unit tests. So I don't expect you to go around doing this. But if you hear about unit testing in the future, or you want to try some unit testing for yourself, the sort of ideas and the libraries that can help you do that are out there. JUnit is a very common unit testing framework for Java. There are other ones as well, but JUnit is very common, and again, that's what your homework uses. So you've been running these in Eclipse this semester. You can go look at that code. That code is there in that tests folder. I have you, right-click on the file and then say run as unit test to run it. You can open up that file and take a look. Those are just tests that are written by. Originally, the code was written by another professor, but I've gone in and made changes and added tests and whatnot to it. So you can go in and you can take a look at the code. You probably won't understand everything that is in there, but all the tests are there. So whenever you run those tests to try to get that green bar, that's just running the code that's in those test cases. So beyond that, beyond sort of throwing in some output statements, some prints or something, and beyond sort of unit tests, is actual debugging tools. There's programs called debuggers, and sometimes they're standalone. So you could go download a standalone debugger, for instance, and sometimes they're built into the programs you're using. So Eclipse itself does have a built-in debugger, and so we're going to use that today. The nice things about debuggers is that they give you a lot of information very, very quickly. If you learn to use a debugger well, you actually can totally skip the stage where you're putting in print statements. In one of the classes I teach for juniors, the parallel programming class, I sort of show some stuff about debuggers, but I expect sort of students to sort of know how to use them. So it is worth messing around with this. It's worth sort of thinking about using a debugger when you come across a problem, because then you will get used to using them, and it will become sort of second nature to be like, all right, I need to do this step and then this, and then I can check what's going on in my code. So debuggers themselves are nice because they allow you to step through your code one line at a time. Normally your code executes really fast. With a debugger active, you can execute one line at a time whenever you want to. And at any point in your program, you can view all of the variables that you've created and what their values actually are. And if your program is big and complex, you can set a breakpoint. So you can run your program normally up to a certain point and then have your program stop and let you execute the program one line at a time. So there's some really cool features that are very powerful for helping figure out what's wrong with code. And so we're going to look at how to use that today. So debuggers shouldn't be used in sort of situations in place of proper testing. So you should still test different values like we were doing for the guessing game. You still test 0 and 1 and that sort of stuff. But it is an assistive tool. If you find an error, opening up the debugger and using it to try to figure out why the error is happening, you can do it quickly and sort of relatively painlessly for the most part. All right, so Eclipse's built-in debugger has all the normal sort of debugging functionality that you may come to expect in the future after using debuggers for a little while. You set breakpoints, you can start the program in debug mode, that sort of stuff. So I'm going to show you sort of manually how to do all this. Think of this slide as more of a, if you come back later and want to use the Eclipse debugger, this slide sort of tells you how to go about doing some of that stuff. Again, similar sort of thing. We will talk about this as sort of a live thing. So most of the rest of the slides are kind of like this, where they're just giving you sort of a description of what to do. Whereas, of course, in the video, I will give you an actual description of how to do it as we're doing it. So here's that same code that we just worked with, and we sort of had to think ourselves. All right, what's happening when we do this? Are we skipping over this if? Are we not? What are we doing? We're going to run this one again. So I'm going to basically undo all the changes that we made. And we're going to run it through the debugger. So I have a few, and the slides after this are sort of talking about the steps that you would use. So back into Eclipse, let's go back here and get all these values back to where they were. So we still have that same program, but now it's not working correctly again. So say this is for a homework assignment or something. Let's try to figure out what's wrong. I coded this up and I tried it. It doesn't work right. The unit tests aren't saying that they're correct. So what's wrong? The first thing you want to do is set a breakpoint. You need to tell the program a place where to stop so you can start doing all of the debugging stuff. Typically, you're going to put this either at some sort of print line or some sort of calculation line. So I'll usually start it at a print line like this. So way over here in the gutter. So this, in this case, we have the line numbers just to the left of the line numbers. And what it's showing me here is a sort of blue area, but it doesn't have to be blue for you to put a breakpoint in. That's where you double click. So on line 8, I'm going to double click in the gutter. What you should see when you do that is a tiny little blue dot. So it's very sort of non-intrusive. You can add these in and continue doing everything that you normally do when you're programming, but this will tell the debugger that it needs to stop. It'll stop on that line when I run the code. So it will run the initial stuff. It'll run this input line. It'll create the answer variable and the guess variable. But when it gets to this line, it'll stop before it executes it. Once you have a breakpoint set, then we can run in debug mode. There is a button for doing it. The normal button we press to play is the sort of play button here. If you go over one to the left, there should be a button that looks like a bug. That's the debug button. The other way to run is to go to run and then say debug, this one right here. So I say debug. It should bring up a confirmation thing here. This is going to change your perspective. So the way I have the windows laid out is a way that I sort of like it for regular programming in Java. The debug perspective opens up some new windows. So it's just asking you, hey, this is going to switch what your windows look like. So we're going to say switch, and it sort of adds a couple of things. And the program's running. Right now, the program is running. We can tell that because down here in the console, there's the little red sort of stop button here. If that's lit, so if that's sort of highlighted, then we know the program's currently running, and I could click the stop button to stop the program. This line is highlighted. So even if I click off of that line, the print line here is highlighted. That's where the program is right now. So my program's running, but it's waiting. It's waiting at my breakpoint. Over on the right-hand side, this right-hand panel that came up, this shows all of your variables. There's a variables tab, so there's a couple other tabs here, but the big one is the variables tab. So if you look closely, you might have to squint depending on how big this is on your monitor. There's a variable here called answer, and it says the value is 3. That should make sense. We have a variable called answer, and its value is 3. It doesn't show guess in here because I haven't set it to anything yet. We also see input, a variable called input that is a scanner. That's this one here. So this side will show you all of your local variables, the variables that are going on in your program as your program runs, and what their value is. So that's super powerful, because normally I would need a print statement to figure out what the value in my program was for like answer or something. But here I can just see it directly as the program's running. Okay, so then the next question is, how do I get the program to keep going? There's a few buttons that show up in your little top navigation bar up here. They look like little arrows. So one of them is right here. So it's a sort of to the right and then down arrow. One of them sort of looks like a little upside down U with an arrow on the end. And there's another one that's probably not lit that looks like sort of an up and then over to the right arrow. The one that you're typically going to use for the moment is the one that looks like the upside down U. This is called step over. So this just moves you to the next line. Think of it as it runs the highlighted line and then moves down to the next line. So if I click step over, the highlighted line moved down in my code, and notice it ran that print. So now I get a print to the console. And so now we're waiting for the user input. So I can just type in, let's say I type in 1. I press enter, nothing happens because we're still waiting to run the line to read it in. So now I press step over again. Now guess showed up in the variable section with a value of 1. And we're going to run in this if. This is where I can say, all right, my expectation, if I type in a 1, it should go down, it should skip this if here. When I run this line, it should skip this if and go to the next if and then print out the wrong try again. So we take a look here. Where do we go in the next step? It goes down to invalid guess. So we went into this if statement instead of skipping over it. That's not what I expected. So that tells me that, all right, there's probably something wrong here. And of course, we already know that we got to get rid of the equals here. But the debugger just running line by line informed me of that as well. Be like, all right, 1 should work, but it doesn't. It goes into the if statement. 1 should skip this so that I know to look here for the potential issue. If I keep going, so I get the invalid guess, so it printed it out. I do another one, system.exit. It's going to run that line, and now my program is done. So my program is no longer executing. We can't see the little sort of lit up square down here. And of course, you can continue doing this again. You do want to keep doing the debug, running in debug mode. So here I could do that, do the step over, type in a value here. Maybe I want to type in 3. So my guess is now 3. I keep going. I skip. Notice it ran this line of the if statement and it did not do the invalid guess. It stepped over that. If guess is equal to the answer, which it is now, so because I can look at my variables, guess is equal to the answer, let's run this one. Well, that's the incorrect one. I've swapped these out, so it runs that, goes down to the last bracket, and then my program's done. So that's the idea here. That's this idea of using the debugger to step line by line, being able to see all the variables that your program has at any given time, and be able to check and see what potentially sort of branches your program is doing. Yeah, David. So system.exit, I mentioned it briefly last time, but it was just sort of a brief sort of side note. So if you want to exit your program early for any reason, system.exit and then a number in here is what you're going to want to use. So in this case, if you enter an invalid guess, it's not even going to bother checking if it was wrong or if it was right. It's just going to end the program right away. The number you put in here for our purposes doesn't matter. So typically you're going to see me put in a value of 0. So let's say you fix all the errors. Let's say you fix everything, and we're not going to bother here, but let's say you fix everything. You run the debugger a few times, you check all this stuff, and then you're like, all right, it looks like everything's working now. I'm going to go back to coding in my sort of regular Windows setup. There's not really an easy way to do that. At least it doesn't look like there's an easy way to do that. There are a few sort of shortcut keys you can use, and there's a few other options with the settings in Eclipse to sort of automatically do it. But if you're stuck in some windows that are not the sort of the normal programming view that you're used to, you can always go up to Window, Perspective, Open Perspective, and you should see Java here. If you don't see Java in this list, then you can always say Other, and Java should be in that list that comes up. Other just gives you more options of stuff. So again, it's Window, Perspective, Open Perspective, Java. Once I do that, it gets me back to where I was before. So if you're ever in a situation where you're in a new perspective and you don't know how you got there or whatever, you can always open up a brand new perspective, or you can always go back to the Java perspective or the debug perspective if you want to. So that's the idea of using the debugger. This is a very powerful tool. Most IDEs, so like Eclipse or IntelliJ or stuff like that, most of them have built-in debuggers. If you've used, depending on languages you've used things like VS Code or Visual Studio or something, they all have debuggers that are built into them. Some are more feature-rich than others, but Eclipse has a full-blown debugger that you can use to do a lot of different things. Not just what I showed you, but you can use a lot of other stuff you can do with it as well. But this is sort of the sort of beginning debugging stuff. So the sort of beginning stuff that is useful for you guys. Check here. There we go. Okay. So yeah, so that's That's our sort of initial sort of debugging thing. And I put the steps in here as well. Start by putting a breakpoint, all that kind of stuff. Use the step over button that had, all these have shortcut keys as well, so you don't have to be clicking on everything. And then a few steps for messing around with this. So if you do come back to this later on and you want to sort of mess with this again, the slides here have the steps involved. Okay, so this particular one, and I do have this one coded up already, but this particular one I want you guys to mess with. So I'm gonna break you out into the breakout rooms. We will come back after, I don't know, maybe we'll spend like 10 minutes or something. We will come back because I have sort of a wrap-up thing to do, but I want you to mess around with the debugger. I want you to at least run it, make sure you know how to step through all of the code, and see if you can figure out what's wrong with this one. So this one's relatively simple. If you have the slides open from the PDF, you can always just copy and paste this in. Otherwise, you can type it up. I do have it coded here already. So if I run this, for instance, I type in some values. It looks like it sort of runs properly. It's just getting the area of a square. So I type in 5 and 5, I get 25. Looks good. Yeah, whatever. But if I type in something that doesn't make sense, let's say I type in 0 for the length and 4, it says the area is 0. Now, a 0 length rectangle, you're not really going to be able to define the area for that. And if I type in a negative value, I get negative 10. That doesn't make sense at all. So I want you to code this up or copy and paste it into a new project or something, and then use the debugger just to step through the code. Remember, set a breakpoint. So over here in the gutter, for instance, set a breakpoint somewhere. You can put it on the first print, for instance, and then use the debugger. Just get a feel for how it works. That way, hopefully, if you come across a problem in an upcoming homework assignment, it won't be sort of too intimidating to run the debugger in that context as well. So back over to the slides. In the slides after this, I do have some of the steps to go through that, so you can follow these as well if you want to, but I just want you to mess around with this just a little bit. So I'm going to do the breakout rooms. So let me create some of those, and we'll do sort of the normal thing here where we go down to maybe 3 or 4 people. And Dan, I'll make you a co-host here as well. Okay, so I'll just go down to 3 or 4. Feel free to talk about it. See if you can figure out where the problem lies. It might be